For thousands of years, human civilization has been built on energy, from the burning of wood and coal, to the rise of oil and gas, to the renewable revolution of the 21st century. But now, we face a crisis. Our demand for energy is skyrocketing, but fossil fuels are polluting the planet. Renewables, while promising, aren't yet reliable enough to power the world alone. So, where do we turn? There is one element, one radioactive metal, that could change everything. It's been feared, misunderstood, and even demonized. But could uranium be the energy source of the future? Let's find out. Uranium is a heavy metal found in the Earth's crust. But what makes it special isn't its weight, it's its power. Specifically, uranium-235, a rare isotope that makes up just 0.7% of natural uranium, can undergo nuclear fission. But what does that mean? 1 kilogram of uranium-235 contains 2 to 3 million times more energy than the same amount of coal or oil. That means a single uranium fuel pellet, about the size of a fingertip, produces as much energy as a ton of coal. Unlike fossil fuels, nuclear power doesn't emit carbon dioxide while generating electricity. Nuclear reactors provide constant power, running 24/7 without relying on the weather. So if uranium is so powerful and efficient, why aren't we using it everywhere? The truth is, nuclear energy has a PR problem. The word nuclear often brings to mind meltdowns, radiation, and disaster. But here's what most people don't realize. Modern reactors are vastly safer than those built decades ago. Chernobyl and Fukushima were outdated designs. Newer plants use fail-safe mechanisms. And the biggest myth of all, nuclear waste isn't as dangerous as you think. Most people imagine toxic, glowing green goo, but in reality, nuclear waste is solid and can be safely stored or even reused. Traditional nuclear power has its flaws, but what if we told you the future of nuclear energy isn't just fission, but something even bigger? Enter advanced nuclear reactors. These include molten salt reactors, designed to never melt down, using liquid fuel instead of solid fuel rods. Small modular reactors, cheaper, faster to build, and safer than traditional nuclear power plants. Fast breeder reactors, which can recycle nuclear waste to generate even more energy. But if fission is just the beginning, what comes next? While nuclear fission splits atoms apart, nuclear fusion fuses them together. This is the same process that powers the sun, and it could provide limitless clean energy. For decades, fusion has been seen as a dream of the future, but recent breakthroughs suggest that future is closer than we think. The challenge? Achieving ignition, where a fusion reaction produces more energy than it consumes. But if we crack it, we could end the energy crisis forever. Solar and wind energy have come a long way, but they have a major drawback: intermittency. Nuclear power, on the other hand, is always on, but it does require high upfront costs and has a long development timeline. So what's the best solution? The answer may not be one technology, but a combination. Renewables for short-term intermittent energy, nuclear fission as a long-term reliable base power source, and nuclear fusion as the ultimate clean energy revolution. So, is uranium the future of energy? With the world demanding cleaner, more efficient power, nuclear energy is hard to ignore. It's one of the most promising solutions for meeting global energy demands while cutting carbon emissions. With next-gen reactors, safer designs, and even nuclear fusion on the horizon, uranium may be one of our best bets for the future. But what do you think? Is nuclear power the solution, or should we focus on renewables? Will fusion become a reality in our lifetime? What energy sources do you think will dominate the future? Tell us in the comments below. And if you enjoyed this deep dive into the future of energy, don't forget to like, subscribe, and hit the bell icon so you never miss an episode of Spaced Invaders.